Welcome to the second 5G-MOBIX webinar. Let me introduce myself. My name is Pantelis Kandelopoulos, and I'm working at ICCS. I'm responsible for leading the dissemination activities of the 5G-MOBIX project, and I will be moderating our discussion during this webinar. Our consortium organized this webinar in order to present the Spanish-Portuguese Cross Border Corridor of the 5G-MOBIX project and its preliminary findings. Particularly, we will give an overview of the corridor and the related use cases, and the discussion will also include the 5G network infrastructure, as well as the vehicle and roadside one. Moreover, you will be informed about the technical evaluation, user acceptance, and impact assessment aspects. Lastly, conclusions and outcomes from the Spanish-Portuguese Cross Border Corridor will give a comprehensive summary of the work made so far by our consortium and its most relevant outcomes. So, let's start our webinar. But first, let me introduce you our speakers. Dr. George Pereira from the Future Connectivity System Group of the European Commission. He is the project officer of the 5G-MOBIX. Mr. Nicola Tsampieris from ERTICO. He is the 5G-MOBIX project coordinator. Ms. Diana Blanco from CITAC. Mr. Juan Francisco from Telefónica. Mr. Daniel Jauregui from CITAC. Ms. Marta Miranda from CITAC. Mr. Emmanuel Sousa from CCG. Ms. Daniela Carvalho from TIS. And Mr. Joao Moutinho from CCG. This is our agenda and the topics that we're going to discuss during our webinar. And now, I would like to give the floor to Dr. Pereira. Hello, Mr. Pereira.
Okay.
Thank you very much for participating and accepting our invitation to participate in our webinar. It is a really honor for all of us who are working in this project. Hello, and this is we can start.
First of all, thanks for the invitation. I don't want to take a lot of your time. So you have the slides, so it can be shared. Go very briefly over the main points. Let me talk about 5G for connected and automated mobility. Can you just not move to the next one?
Mm-hmm.
Like this, it's very difficult. Anyway, no, you need to move to the next one. So can like this, it doesn't work. Okay, everyone knows that the 5G action plan aims at the coverage of major transport corridors, and not only by road transport by 2025. Next one. As you are aware, we launched a first call on 5G for CCAM, the 3 projects. And combined, there is an overall funding of 63 million euros. And the corridors cover over 1,000 kilometers of highways, and they cross 8 borders. So next one. There are a number of open issues that are not only technological, okay? But the objective of the first call was really to look into the barriers that have towards the deployment of 5G for CAM. The objective is really to provide seamless roaming of CAM services on top of other advanced data services like eMBB. This is a different type of kind of roaming. It is no longer best effort, and therefore this roaming comes with a price. You have to change the network in order to be able to achieve this. In the end, CV2X, together with device-to-device, will allow to launch mobility services, including real-time, on top of advanced data services like MBB and massive IoT. Next one. The major issue is that we have to cover and provide uninterrupted coverage of sparsely populated areas, namely when you're talking about the cross-border segments. And we have to do this, but providing very high data rates and ultra-reliable low latency communications type of services. And this is extremely expensive. And this is one of the issues that needs to be looked at by the projects, so that we can come up with proposals that might include sharing infrastructure, issues like national roaming and the other. In any case, whatever the solution to cover these areas, you need to rely on top of fiber infrastructure along the major highways at least. And this was already part of the Gigabit Society package of 2016. It's not 17, sorry for the mistake. As I mentioned, the next one, as I mentioned, what is important is to provide real-time services. Critical CAM services require real-time connectivity, and current deployments do not allow any of this. And this is not only a question of the antennas, it's a question of the underlying network, and namely the backbone and the MAC, as you will get back to this. And this, again, requires considerable investments in order to deliver this. Next one. Next one, please. So what are the challenges? No, can you go back? What are the challenges that have been already identified? As I mentioned, these barriers were one of the main, in fact, these barriers were one of the main goals of these projects. The challenges are not only technological, as I mentioned, but also have to do with business models. And here is the competition and eventual cooperation between telcos, automotive, and road operators, but also legal and regulatory, not to forget the issues of security, reliability, availability, and liability. So these have been started to be identified by the project. So next one. As we moved along, we launched a second call for 5G for CAM, but now we are not only aiming at the automotive, but also at rail cross-border corridors. The result of this call was 5 new projects that are to be launched in September of this year, representing a funding of additional 40 million euros. So the next one. So overall, the Commission has already put into this preparatory phase over 100 million euros in cross-border corridor projects. So next one, please. Next one, please. Are you okay? Is anything happening there?
Well, I think that Pantelis has a connection issue. Yep. George, hi. I'm sorry. Can you proceed even without visual feedback of the presentation? Do you have it by you so that you can proceed?
And reducing congestion. Okay, next one. To fund the 5G corridors, we are going to move from this Horizon 2020 large-scale testing and pre-deployment in the context of the cross-border corridors to large-scale deployment. Next one. But this means that in the Connecting Europe facility digital, we are going to launch a major public financing support for accelerating private investment in 5G infrastructure along highways, known as the 5G corridors, to enable CAM solutions. It is expected that the funding for these 5G corridors will be a significant part of the 3 billion requested by the Commission for CEF Digital. I would say we hope to have the 1 billion euros for this. Next one. So we are. It is important to understand this. We are moving from a pre-deployment phase of 100 million to a first deployment phase of 1 billion. So this means that the current projects have really to contribute to the definition of this deployment plans. And this is done in the context of the strategic deployment agenda. Next one, which has been developed in the context of the 5G PPP Automotive Working Group, which is at the moment chaired by the coordinator of 5G Croco. And there, a common strategic deployment agenda was developed, defining the roadmap for implementation and providing recommendations for deployment and geographical rollout of 5G over the corridors. So next one. The objective of the strategic deployment agenda is to attain societal benefits, a longer-term vision of safer rides, efficient rides, connected rides, but also, and this is extremely important, especially in the current context, the increased economic competitiveness at global scale. So Europe needs to be a major player in CAM, 5G for CAM. This requires a shared vision. Next one, which is in the document. But as I mentioned, what is important is this economic development, and therefore we need to develop a CAM ecosystem in Europe. Okay, Europe has to shape a complex connected car ecosystem involving many different stakeholder communities, which are already prefigured in the current cross-border corridor projects. Next one. The key drivers for accelerating the infrastructure rollout are standards, which are in the process of being defined at 3GPP. Regulatory innovation, allowing for co-investment, sharing options, access-related regulatory schemes. We need the regulatory flexibility here because, as I said, the investment required investment is very high. And then access and data sharing issues, network slicing issues, cybersecurity, and important one, availability and coordination of spectrum between for 5G, for CAM, namely in neighboring countries. Next one. Next one, please. Okay, so the plan is to get pan-European 5G corridors for connected intermittent mobility, aiming at uninterrupted 5G coverage by 2025, combining private investment with public funding, especially in challenge areas, again, low, sparsely populated and peripheral areas. We have already started with large-scale testing in Horizon 2020, as I said, over 100 million euros, which is quite significant, and we hope to have to launch large-scale deployment using CEF Digital with up to 1 billion euros. To what you have to add other public funding sources, including EIB and national funding. Next one. So this 5G strategic deployment agenda for CAM was elaborated with the participation of stakeholders, all stakeholders, and serves as an input for the CEF pillar of the Smart Networks and Service Partnership, which will be looking to 6G, 5G, beyond 5G. Next one. The same way we developed one strategic deployment agenda for automotive, we are now launching a similar exercise for rail, but this is still in the process. So next one. How can we, what we need besides this money, okay? This direct money for 5G corridors. We need to really continue investments in fiber infrastructure. Next one. Without this fiber infrastructure, we will not be able to deliver the real-time critical services that I mentioned before. As I said, this was already part of the telecom package of 2016, and this is the correct date. Next one. But we are now, if you look at this 5G action plan timeline, we are now exactly at the moment where you need to launch substantial investments in fiber infrastructure and small cells. But the small cells is more for city deployments. But the fiber infrastructure needs to be pervasive. We need really now to commit to these substantial investments in fiber infrastructure. Next one, please. So how can the projects help the preparation for cross-border deployment? Next one. The projects have to make an exercise defining, establishing the current deployments in terms of base stations and core deployment, which will serve as a baseline for future for the analysis. Then they have to look at the 5G deployment plans without CAM. Okay, this is the evolving baseline that is then enshrined in the licensing conditions, which differ from country to country. And now the project needs to look into what is required to deliver CAM on top of this baseline. But we want to do it faster, okay? We cannot wait until 2025. This process is a very slow one. We need to start as soon as possible, okay? Next one. Therefore, the projects need to start looking into the drivers of this deployment. And they are traffic requirements from the automotive sector, which evolve in time necessarily. But we need to understand that different classes of services will require substantially different data rates. And I gave the example 1 megabit or 10 megabits or even 100 megabits per second per vehicle. There is the whole issue of peak versus average data rates, but this has to be discussed. Next one. Next one, please. We need to understand that on top of these CAM services, there are also non-CAM, the one before, please. There are also no CAM services, and they have to do with the EMBB and massive IoT traffic that is expected. And there are some numbers of 100 megabits per second per car on EMBB data. And this seems to be consensual, which if you go back to the previous slide, you don't need to go back because it takes time. If you go back to the previous slide, means that the 100 megabits per second per car for CAM is not very reasonable, okay? So I would say that 100 megabits per second per car for CAM is an overestimation. But in any way, this needs to be analyzed. On top of this, CAM and non-CAM traffic, the road operators are interested also in a lot of data. They want to have wireless high definition cameras to support ITS command and control. But again, we have to look here at to realistic deployments in terms of road operator. Next one. Okay. Next one. So how can the projects again help with this? The projects in the context of their exploitation plans are expected to provide reasoned plans towards 5G deployment in cross-border scenarios. Next one. What does this mean? It's not only that you have to take into consideration, okay, the baseline, next one please, the baseline and then the planned deployment, okay? But you also have to really take into consideration a realistic plan over 3 to 5 years, the so-called ramp-up strategy. So you need to look at the current coverage of the cross-border corridors. You need to look at the presumptive growth of traffic, both CAM and non-CAM, and then to look at how are you going to deploy this. So the objective is to start a discussion on the required investments, but they will come from MNOs, road operators, but also from the automotive sector, okay? This means that the stakeholders have all to be involved, and we have to look into cooperation models. As I said at the beginning, the current business models are very competitive, okay? It's more MNOs versus OEMs versus road operators, but given the size of the investments required, we are certainly looking towards cooperation models that will provide a win-win-win situation to all involved stakeholders. And one of the major things has to do with cost reducing solutions through infrastructure sharing, national roaming eventually, or other solutions, okay, that can rely namely on local operators, okay, that might rely on local operators. Next one. So what is the mechanism? Is the project should provide target contributions from all different players, from all different stakeholders, for the preparation of trial M's and long-term exploitation. You need to check existing studies and information, namely, for example, in the case of the OEMs, what are the expected data rate requirements for different classes of services? Then the three projects, and eventually the new ones, but the three projects should come together and try to build a common perspective. What was identified was the need to eventually launch targeted studies that extend beyond the current project beneficiaries, so that you can have a proper say from all different stakeholders. Why do I say extend beyond current project beneficiaries? Because in some of the projects, or in fact all of them, there are beneficiaries that are not present as beneficiaries. Sorry, there are stakeholders not present as beneficiaries, but they are, for example, in the advisory board and otherwise. So these studies should really look into the broader constituency, and that's why these targeted studies should be conducted by someone that can be seen as a neutral party. Next one. So, as I said, all of these should be put in the context of the exploitation plans, okay? We need to look into business, market, and ecosystems towards long-term exploitation on a use case-based relationship among stakeholders. We know that 2 projects, including MOBIX, had planned business model deliverables in April. I would like to know where we are, and 5G Croco has already available a first version of the business model. So we need to look together, use the current business model information in order to build this stage deployment models and requirements. The idea was initially to have a first meeting at the ITS Europe Congress in Lisbon, but since it was cancelled, I think we need to look towards a joint workshop early in October to discuss these matters. Next one. The objective again is to have a future-proof deployment planning that takes into consideration different scenarios, because as I said, the 3 projects have a different cover different scenarios as well. And the Commission will provide input from the EDAT study concerning coverage of low density rural peripheric areas for the CEF2 program. Next one. Okay. So I know I was very brief and the slides didn't jump really properly, but you'll have access to the slides. Anyway, I was just trying to relaunch here the requirement for this business, for this exploitation plans that we need to have before the end of the year. Okay.
Okay. Thank you. Thank you very much, Mr. Pereira, for your presentation and for all the valuable information shared with us. As I said before, we are really happy, and it is an honor for all of us working in the consortium that you accepted our invitation and participate in this webinar. Now, I would like here now is Mr. Nikos Tsamperis. We'll go to the next speaker. He's the project coordinator of 5G-MOBIX. He's from ERTICO, and he will talk us about the project. Hello, Nikos.
Yes, hello there. Hey, so thank you very much, Pantelis. And also I would like to thank George for this very good presentation he gave us, and talking about the vision and the strategy in the field. So I'm going to go back down to basics. I give the project presentation, and this will be mainly for the benefit not of the project participants, but mainly for the newcomers in our company, in our webinar. So please, I invite your patience because I'm going to talk about basic things. So MOBIX, 5G-MOBIX is a 3-year H2020 project of in November 2018. And it brings together 55 partners from 10 different countries. And what are the objectives of it? Really, we want to see, George mentioned a lot on this, just mention the objectives of the project specifically. So we try to see the benefits of 5G within the CCAM, the Cooperative Connected Mobility context, and to provide deployment scenario and contribute to standardization. This is the overarching objectives, and how we are going to address them at a high level by developing a testing functionalities for high-level automated vehicles using 5G core technology innovations, and all this running of trials, cross-border trials and evaluation. So going to this slide, we see in order to meet these objectives, then we have to follow precise steps. And these steps are the requirements first, formulation of the requirements for 5G CCAM trials, And then we have to establish the corridors to carry out these trials. Then we have to try out the technologies, to evaluate and validate them, perform analysis, cost-benefit analysis, varied multi-operator domains, and then assess and explore new business opportunities. Then we have to really come up with the 5G deployment scenario and recommendations, including ex-border context. We need to sustain the standardization and work into the spectrum allocation. And having completed all these steps, we are aiming to scale up and replicate for a global 5G CCAM adoption. Now, the 5G-MOBIX follows the phases you see on this slide. So the first phase 1, is pertinent to the deployment requirements, and we need to assess the, sorry for a second. Yes. So we need to, the phase 1, the deployment requirements, we need to assess the 5G CCAM requirements, but on major EU transport routes. Then we select and map suitable use cases for 5G-MOBIX corridors. And then we have, as I mentioned earlier, to perform technical and cost-benefit analysis for each corridor, but use case specific. Following the phase 1, we have the phase 2 development, integration, and trials. So there we develop the corridors by integrating the 5G technologies. We then have to carry out the trials to assess the 5G capabilities for CCAM and identify business enablers. Phase 3 is the evaluation and dissemination, and through this we evaluate the 5G technical aspects, but for different types of stakeholders. And then we have to make sure that the project outcomes and innovations reach all stakeholders involved. Finally, we have the deployment strategy in phase 4, which comes up with a 5G deployment plan containing inputs for regulation, inputs for interoperability, and recommendations for standardization and new business models. This slide relates to the overall concept and trial architecture. Main point here is trials facilitated and are facilitated through 2 network slices, eMBB for high data throughputs and URLLC for low latency connectivity. And of course, these are trials at the local and cross-border environments with a really challenging automated driving scenario. Now, regarding the overview of cross-border corridors and test trial sites, we have 2 cross-border corridors. We have 4 European trial sites. We have 2 trial sites in Asia. We consider 5 use case categories. We try to trial 18 user story scenario. We employ level 4 automated vehicles, 35G DNBs, and we have 9 experimentation frequency bands. The use case categories I mentioned, there are 5 in our project, and they are pertinent to advanced driving, vehicles platooning, extended sensors, and remote driving and vehicle quality of service support. Regarding the 5G-MOBIX cross-border corridors, they really span the width of Europe. We have at one end the Spanish-Portuguese corridor, and that's the main theme of our webinar today. So my colleagues will further elaborate and discuss in great detail. I just want to mention that Porto Vigo is the pan-European cross-border 5G corridor for CCAM, and there are some very interesting use cases, advanced use cases to be considered there regarding lane merging, automated overtaking, and maps update. And on the other end, we have the Greek-Turkish corridor. And again, we have some interesting use cases relating to track platooning, to see what I see, and increased driver awareness and reduced anxiety levels. Sites come to complement the two cross-border corridors located in Versailles in France, Berlin and Stuttgart in Germany, Eindhoven, Helmond in Netherlands, in China and South Korea. As I mentioned earlier, 18 scenarios will be implemented, will be trialed in the cross-border corridors and the complementary trial sites, and they synthesize a very complex technological picture overall. All these, let's say, technology innovations and the challenges that this project presents are being carried forward by a great consortium. We have 55 partners there, and we cover all critical aspects of projects of this kind. Like we have telecom and connectivity expertise. We have automated driving companies. We have entities coming directly from the business sector, and of course, not to forget the R&D, research and technology institutions and universities. Here, just want to mention that the project carries a value of 27 million. The EU funding has been 21 million. The coordinator is ERTICO, and 5G-MOBIX, George made reference in his talk previously, is a complementary grant to the following projects: ICT 17 5G, 5 Genesis, 5G Vimy, and ICT 18, 5G Carmen, and 5G Croco. I would like to mention here in passing that this webinar is being hosted by ERTICO as a part of the ERTICO Academy initiative, which really provides training, capacity building for the deployment of ITS. So we have face-to-face and online training in smart and sustainable mobility, which is designed for public authorities in Europe and beyond, and provides for courses online and interactive for all levels. I would like to thank you very much for your patience. I tried to give this presentation as fast as I could, just to cover up for the time that passed due to inherent in this kind of activities like webinars, connections, etc. So thank you very much.
Thank you very much, Mr. Tsamperis, for introducing us the project, and of course a warm thank you to ERTICO Academy for hosting this webinar. So I'm addressed now to the participant. If you have any questions, please write them in the chat box and mention the speaker that is addressed to. So if you have any question regarding Nico's, for example, if you have a question regarding Nico's presentation, please
I think that we lost. I think we lost Pantelis again. So the next presenter, so that we can move on, will be Diana Blanco from CTAG. Diana Blanco from CTAG will present us with an overview and also will explain the use cases that the cross-border between Spain and Portugal will include in the activities of 5G-MOBIX. I would give the floor to Diana. Hello, Diana.
Hello, can you hear me?
Hello, thank you. Yeah, loud and clear.
Okay, can you see my screen? Thank you.
Perfectly.
Good afternoon, everybody. First of all, I would like to introduce myself. My name is Diana Blanco, and I'm the project manager, the European project manager of 5G-MOBIX project at CITAC, the Automotive Technological Center in Galicia, being CITAC the leader of the Spanish-Portuguese Cross Border Corridor. Secondly, I don't want to begin without first thanking all those who have made this webinar possible, and especially Pantelis, George, and Nikolaos for the presentations prior to this one. Having said that, I will provide an overview of the Spanish-Portuguese Cross Border Corridor, the user stories, the locations where they will deploy it, and finally, we will comment on the contributions different trial sites to our cross-border corridor. First, I would like to introduce the Spanish-Portuguese cross-border corridor. This corridor connects the two cities between Vigo and Porto through different roads and highways. Specifically, the cross-border is located on the frontier between northern Portugal and Spain, crossing the Minho River through the two international bridges. International trade, as well as large passenger commuting flows, are of great importance and provide ideal conditions for the execution of the trials in 5G-MOBIX project. In relation to the consortium, our Spanish-Portuguese cross-border corridor is composed of 23 partners and has 3 more partners belonging to the advisory board and associated partners. It is an extremely strong consortium, as it includes the main companies of the sector in different areas that will contribute to the success of the Spanish-Portuguese cross-border corridor. As I already mentioned, the leader of the Spanish-Portuguese cross-border corridor is CITAC, but we can do with the help of the CCG as coordinator of the Portuguese side. Furthermore, we count on road operators from both countries and city councils who will advise on the best way to execute the tests, MNOs and telecommunication partners that will enable the deployment of the 5G network, OEMs that supply vehicles, institutes, technological centers and universities that will allow to go off the hand of the state-of-the-art of the most advanced technologies, testing and homologation companies that will provide an objective vision for the evaluation of the project, technological companies that will contribute to the deployment of the different user stories at different points, and of course, as I have said, our associated partners and advisory board. Perhaps the strength of this corridor is best seen if we identify the partners who bring value to each of the project work packages. The partners of the Spanish-Portuguese cross-border corridor participate in each work package from the definition stage to the final stage of results dissemination. But if we want to see the synergies of our corridor, we must go to the next slide, where it is shown that each partner has its specific task in the cross-border corridor, and together we form a perfect gear. Antennas, MEC, core, ITL center, vehicles, permits and licenses, recommendation, pedestrian detection systems, cockpits, radars, technical evaluation, impact assessment, user acceptance, deployment enablers and dissemination. Each partner has its specific contribution along the entire project value chain. Well, at this point, I will focus on presenting the different user stories that will be developed in the present project by the Spanish-Portuguese cross-border corridor. First of all, we have the lane merge. In this case, an autonomous vehicle, the blue one, will be incorporated into a motorway. In the main lanes, there will be one autonomous car, one connected car, and one non-connected or legacy vehicle traveling through them. The autonomous and connected cars send their position to the corresponding MEC thanks to the installation of the nearby 5G antennas. It is necessary to consider that both MECs are connected so that they share information. In the case of unconnected cars, they will be detected by radar located for this purpose. In this way, both the OVU of the vehicles and the RSU of the radar generate messages with information of position, speed, and orientation, and send this information to the network. The MEC receives the messages transmitted by the vehicles and the radar and forwards them to the nearby vehicles so that the blue vehicle that joins the motorway receives information regarding the vehicles that are traveling on the main roads of the motorway. The vehicle then predicts the trajectories of the detected vehicles and calculates the collision risk. If necessary, the speed of the car is adapted and the incorporation maneuver is allowed. The next user story is the overtaking. In this case, as you can see, an autonomous vehicle is driving on the right-hand side of a motorway. I mean the blue one. In front of it and behind it, there are bulky and unconnected vehicles that are traveling at the same speed and significantly reducing the vision of its sensors. Another autonomous vehicle runs in the left lane, 100 meters behind the first vehicle at a higher speed. The OVUs of the two vehicles will generate messages containing position, speed, and orientation information and will be sent to the network. The MEC receives these messages and forwards them to the nearby vehicles so that the blue vehicle receives the information from the second one in its OVU so that it can check the safety and the overtaking maneuver. This is when the overtaking maneuver is performed, or if it is not possible, the maneuver is cancelled by the blue car. The next one is the HD maps. In this case, an autonomous vehicle, again the blue one, is driving along the highway and receives a message from the ITS center notifying a roadworks event. The OVU of this vehicle receives the information, compares it with information on its map, and concludes that this internal map is outdated. So it asks the driver to take the control and starts recording what sensors see. When the work event ends, on the one hand, the blue vehicle continues its route in autonomous mode, and on the other hand, the OVU sends the data recorded by sensors to the ITS center, which processes it and generates a new HD map. This new map is sent to the nearby vehicles, in this example, the white one, so that they can autonomously overcome the work event. We have also the three different user stories in relation to a bus. The first one is the multimedia service for passengers. In this user story, the bus passengers will have tablets to be able to enjoy high-quality multimedia content thanks to the 5G network. And on the other hand, the bus will also have a 4G camera installed on its windshield that will allow the sending of the front view in real time to the control center. And finally, for the bus, we have the HD maps. This case is similar to the previous HD maps, with the difference that the bus will not be an autonomous vehicle, but a manual one. In relation, finally, we have two more user stories related with an autonomous shuttle. And in this scenario, the CITAC autonomous shuttle is performing its routes in an autonomous mode along the bridge. At both ends of the bridge, there are areas without visibility of pedestrians. So in both cases, pedestrian detector systems will be installed. This pedestrian detection system sends the detected information to the MEC through the 5G, and in addition, some pedestrians will carry a 5G phone with an app that will send information of their position to the MEC. Then, the MEC sends the messages to the ITS center and the shuttle 5G OVU. The shuttle then brakes or stops in case there is a risk of accident, And when the pedestrian leaves the path of the shuttle, it resumes its autonomous route. And finally, we have the remote driving. In this scenario, which will be located on the same bridge as the previous one, the SITAC autonomous shuttle is performing its route in autonomous mode until in the middle of the bridge, it faces a static object that blocks its route. So it stops in a controlled manner. After a while, the shuttle notifies the control center about the blockage and asks it to take the control. The control center remotely drives the vehicle until it has overcome the obstacle. And once this is done, the autonomous mode would be reactivated and the SITAC autonomous shuttle can continue its route autonomously. Well, at this point in the presentation, having seen the different user stories that are raised in our cross-border corridor, I would like to show in more detail the specific locations where the test will be carried out. As I mentioned before, our corridor is developed between Vigo and Porto, where the user stories related to the 4K monitoring and the multimedia service for passengers in the bus will take place. At the Portuguese trial site level, the lane merge scenario will be deployed on the A28 located near Porto. At the Spanish trial site level, the user stories will be deployed on the A55 motorway for all the cases, lane merge, overtaking, HD maps, and so on. And finally, at the cross-border level, the scenarios will be deployed on the two international bridges linking Tui and Valencia. Specifically, in the so-called old bridge that you can see in the image, officially inaugurated in 1886, both shuttle scenarios, the VRU cooperation and the remote control, will be deployed. And finally, the remaining use cases, lane merge, overtaking, and HD maps, will be deployed on the so-called new international bridge. In relation to both bridges, meetings have been held with the different road operators of both countries to coordinate the logistics and permits to be able to carry out the different international scenarios. And finally, and to finish, I would like to highlight the contribution of the different trial sites to our cross-border corridor. Thus, the trial sites from Finland, France, the Netherlands, and Germany will provide different contributions that will add experience and value to our cross-border corridor. The concrete contributions from all of them that you can see on the slide will be explained in the technical evaluation section. So, once the Spain-Portuguese cross-border corridor, our consortium, the use cases with their respective locations and the contributions for other trial sites have been presented, I give the word to our colleague Juan Francisco, who will show the network architecture and the progress made. Thank you very much for your assistance and your attention. And please keep safe.
Thank you very much, Diana, for your presentation and for informing us about the use cases and giving us the overview for this. I'm addressed to the participants of this webinar. If you have any questions, please write them in the chat box and mention the speaker that you would like to ask. And at the end of this webinar, we will address back to the speakers and ask them the questions that you have raised. Now we will continue with the next speaker. Here now is Mr. Juan Francisco, Open RAN and New Radio Solution Analyst. He's working at Telefonica. He's the 5G infrastructure MNO, and he will talk about the 5G network infrastructure. So hello, Juan.
Hello, thank you,
Hi.
Pantelis, for the introduction. One moment. Can you see my presentation? Oh, okay. Okay, can you see
Yes.
it? Okay.
Yes, yes.
Hello, everybody. First of all, I'm going to present an overview of the infrastructure that we are considering in 5G-MOBIX. Then I will talk about the MNOs interconnection topic. And finally, I will comment about the RAN deployment. Okay, network overview. The Spain-Portugal Cross Border Corridor is considering the non-standalone option 3X architecture, but this could be upgraded with the standalone architecture in case it is available and it is feasible to install it before the end of the project. The network comprises 8 GNODs, which work in the frequency band of 1.8 GHz for LTE and 3.5 GHz for 5G. 4 of these nodes are located in Spain, and the other 4 are located in Portugal. All of them covering the areas where the test will take place. In order to accomplish with the stringent requirements that are imposed for the CCIM services, we are going to deploy 1 meg per country, working as a local breakout of the traffic. In the Spanish side, the MEC will be located at the edge of the network, several hundreds of kilometers away of the core. And in Portugal, the MEC will be central, situated in the same place as the core. Regarding the roaming configuration, we are considering the 2 existing solutions for the testing, home routing and local breakout. This is an schematic that shows the overall architecture of the solution that will be deployed. It shows 2 different traditional networks, one in the Spanish side with the core located in Madrid and the MEC located in Vigo, that is a city near of the area that we are testing. And the other network in Portugal, where the core and MEC are co-situated in Braga. One of the most important parts of the architecture for this project is the interconnection of both networks through a direct IP interconnection of the MECs. The interfaces that will be connected are S6, SA, and S10. These interfaces will be exchanged between both networks in order to ensure the handover and roaming procedures between the 2 MNOs, and also for exchanging the information between the application that will be running over the MECs. Okay, regarding the MNOs interconnection, there are 3 different options to make the interconnection of the MNOs, each one having its advantages and drawbacks. The traditional option is to interconnect both networks through a GRX provider. This solution is the most scalable one, but this option introduces a huge latency due to the thousands of kilometers that are not compatible with CCIM services. The second option is to interconnect the core of both MNOs, one located in Madrid and the other in Braga, Portugal, but this solution still doesn't accomplish with the most stringent requirements of V2X services. Finally, the option that we are going to implement is the direct interconnection of the MECs. Despite it is the less scalable solution, the solution is the only one that can reach the latency requirements. For the roaming scenarios, as I said before, we are going to test 2 options, home routing and local breakout. Local breakout is the optimum solution in terms of latency because the user is connected to the visited network that is closer than the home network. The problem of this solution is that the service interruption occurs during the transition from the home network to the visited network. In the other hand, we have the home routing solution that we foresee as the best option for V2X services because the continuity of the service gets improved. But in this case, the problem is that the latency increases proportionally to the distance towards the local networks where the user keeps connected. We think it will be really interesting to take results from both options in order to compare the numerical results and to take conclusions about the feasibility of each options in terms of two main parameters that are service interruption time and latency increments towards the home network. Regarding the RAN deployment, we are going to deploy 8 GMOBIX total, 2 in Portugal, covering a section of the highway near of Porto, 2 in Spain, covering the CTAG facilities and a section of the highway between Vigo and the cross-border. And finally, we will have 4 nodes covering the cross-border area. Focusing in the cross-border area, in the Spanish side of the cross-border, we will have 2 macro cells composed of 3 sectors. One of them covering the area of the new bridge, where we are going to test use case 1 and use case 2. And the other GNodeB will cover the old bridge, where we will test the use case 3. Those locations are the ones that actually are being used for commercial 4G network. For that reason, we will use 2 different MPLNs in order to separate commercial traffic of the pilot traffic. And the 5G frequency band that will be used will be band N78. In the Portuguese side of the cross-border, the RAN solution will be composed by 1 axial macro base station of 2 sectors, which will cover the new bridge, and 2 small cells of 1 sector each one that are going to provide dedicated coverage in the old bridge. The frequency band that we are going to use will be 3.7 GHz for 5G and 1.8 GHz for the anchoring in 4G. Finally, one of the challenges that we foresee to make the test is the cross-border area. In the cross-border area will be due to the fact that the radio conditions change dynamically, and it's hard to define the handover area where the user changes from the home network to the visited network. For this reason, we will have to adjust and fine-tuning the radio parameters, as for example, A3 event offset, time to trigger, electrical downtilt of the antennas, or transmission power. All of this in order to minimize the area where the handover could take place, being able to measure the handover and roaming parameters during the maneuver take place. Thank you all for listening, and I hope you found it interesting.
Thank you very much, Juan, for your presentation. Now, I'd like again to ask participants if they have any question to write us down and send it through the chat box and mention and please mention the speaker that you are addressed to. Here now is Mr. We will continue to the next speaker. Here now is Mr. Daniel Jauregui, connectivity technician at CTAG. He's technical coordinator of the Spanish-Portuguese Cross Border Corridor, and he will talk about vehicles and roadside infrastructure. Hello, Daniel.
Hello, good afternoon, and thank you, Pantelis, for having introduced me.
Thank you.
I hope you can see my screen correctly. Well, my name is Daniel Jauregui. I work as the technical coordinator of the 5G-MOBIX project in CTAG, and I will explain some details about the vehicles and infrastructure of our corridor. So, go on. The contents of this presentation will deal with the vehicles used for the tests, the CCAM infrastructure, which includes the roadside infrastructure, the remote control infrastructure, and the cloud infrastructure. And finally, we will highlight the most relevant issues regarding security and privacy. Let's go on. In the Spanish-Portuguese cross-border corridor, we will make use of 6 vehicles. First of all, we count on a commercial bus from Alsa Company, which covers a regular route with passengers between the cities of Vigo in Spain and Porto in Portugal. For adapting the bus to the project needs, it will be equipped with several devices such as tablets for the users, high-resolution cameras, sensors, and 5G communication devices in order to provide the vehicle with connectivity. So at the end, this will be a manual, connected, and sensorized bus. Following, we count on 4 connected and autonomous cars provided by CTAC. These vehicles can act as autonomous, just connected, or even unconnected manual ones, depending on the purpose of the test. These vehicles are equipped with a set of sensors, computers, and a hybrid communication unit with 5G capabilities, among other communication technologies, so that they can satisfy the project needs. For the tests, 4 vehicles will be used in total of this kind, 1 Volkswagen and 3 Citroën. Finally, the Spanish-Portuguese corridor counts on an autonomous electric shuttle, designed and developed by CTAC almost from scratch with just an electric vehicle platform. This vehicle is equipped with several sensors, computers, and the already mentioned hybrid communication unit. Now it's the time for the CCAM infrastructure. This slide aims to depict the whole interconnection of the CCAM infrastructure in the Spanish-Portuguese Cross Border Corridor. Here we can find the roadside elements in the bottom, the remote control infrastructure in the middle left, and finally the cloud infrastructure on the top. But let's take a closer look. Roadside infrastructure can be split in 2 groups. The first one involves vehicle detection systems like traffic radars. Traffic radars are used for extending the field of view of connected cars by detecting any vehicle, even connected or not, running in a certain area, and allow to cross-validate the information received directly for those connected vehicles. Moreover, traffic radars allow to collect auxiliary data related to the pilot execution, so the evaluation is enriched with additional information that will increase the quality of the conclusions derived. Those traffic radars will be connected to a 5G RSU that allows them to spread the detection data through the 5G network. The second group of roadside infrastructure involves the road user detection systems. Under this group, we enclose elements that notifies vehicles about the position, speed, and heading of vulnerable road users through the 5G network. The systems aim to warn nearby vehicles about the presence of users and to help avoiding accidents with them. Pedestrian detector systems are fixed elements based on camera or radar technology and strategically located in order to detect any road user in a certain area, for instance, a low visibility area of the road. The systems publish the generated information through the 5G network thanks to the connectivity provided by a 5G RSU. On the other hand, 5G smartphones will be used as a tool for individual road users' position notification. An application installed in the smartphone will publish information to the 5G network about the position, speed, and heading of the user, warning nearby vehicles about its location. The following CCAM infrastructure element is related with the remote driving of vehicles. For this purpose, a remote control center is being developed, equipped with a set of tools for operators driving remotely. This set of tools are connected to the 5G network and more concretely has direct connection with the Spanish MEC in order to assure the low latency needed for this kind of application. The last group to talk about regarding the CCAM infrastructure is the cloud and edge infrastructure. First, the cloud side. In the Spanish-Portuguese cross-border corridor, we are developing 2 similar ITS center platforms that will be deployed in each one of our networks, one in Portugal and one in Spain. These platforms are composed of 2 different modules: the traffic management and monitoring module, which allows operators to monitor and track connected vehicles, as well as to generate traffic events like roadworks, accidents, etc. And the HD map processing module, which is responsible for processing the sensor data recorded by cars, and generating a new HHD map for updating the vehicle swarm. Finally, we have to consider the edge side. In our corridor, each network counts on an individual MEC. Both MECs, even the Portuguese and the Spanish one, runs the same sets of applications. A remote control interface application that implements a remote driving messaging protocol in order to ensure the communication between the control center and the vehicle being controlled, even if the second crosses the border and changes the network. And second, an MQTT broker, that is the core of the communication between the roadside infrastructure elements and the vehicles. This application works as a central node for most of the communications in each side of the border. But even in the border, MQTT brokers of each MEC share information in order to interconnect nearby elements, roadside of vehicles, physically connected to different networks. The flows of messages will be explained and depicted in the technical evaluation section of this webinar. Before the end of this presentation, I would like to mention some important points about security and privacy. Communications and performance in cross-border corridors complicate things, since they must deal with different countries, with different MNOs in each one, and of course, with different security and privacy concerns in each side of the border. We would like to highlight here just the most representative security issues in cross-border scenarios. The interoperation of different trust domains in order to protect CITS messages and to provide data integrity, non-repudiation, and other interesting security attributes, an asymmetric cryptography method is applied. This implies the usage of public key infrastructures, PKI, to issue certificates. European countries use the same PKI infrastructure, avoiding trust issues in the internal borders. However, in external borders, vehicles connected to their respective MNOs may not trust each other due to the absence of a common PKI and ignore the content of CITS messages exchanged. As a result, the respective vehicle groups would be invisible to each other, which could lead to application malfunction or even accidents. The second issue is the application of different data privacy protection laws. The European General Data Protection Regulation, GDPR, regulates the protection of CITS messages, CAMs and DEMs, for instance. As they are also considered personal data due to sensitive information like the vehicle identification number that could be used by unauthorized parties, this issue becomes more complex to handle in the external European borders where the GDPR is not enforceable. Solutions like identity pseudonymization could considerably empower the user protection against traceability and should be part of any cross-border deployment. And that's all for this presentation. Thank you very much for your attention.
Thank you very much, Daniel. Now we will continue our webinar with the next speaker. Here now is Miss Marta Miranda. She's a project engineer at CITAC. She's the technical evaluation leader, and she will talk us about the technical evaluation. Hello, Marta.
Hello. Thank you, Pantelis. Thank you, everyone. Hi. Okay. I'm going to talk about the progress on the technical evaluation that the Spanish-Portuguese corridor has performed so far. So first, I will provide an overview of our approach based on the current development of the project, and then I will present some preliminary results on the configuration of our 5G nodes in the border area and also the capabilities of some of our 5G tools. Okay, so let's start with the overview. Okay, the strength of our corridor is the implication of a significant number of partners in the 5G-MOBIX stacks somehow related to the technical evaluation. To harmonize all our efforts, we have created a Spanish-Portuguese working group at the beginning of the project to work on the chain from the data collection to the final analysis of the technical KPIs. Okay, the architecture of our user stories was designed in such a way we are going to be able to assess the 5G data flows between the user equipments and MEC, ITS center, or internet. In this slide, we show the first case, the 5G data flows between the user equipment and MEC that applies to our advanced driving and remote driving user stories. In these user stories, the applications are installed in the MEC. This architecture is because of the requirements in these user stories of very low latencies. So in the slide labeled in red, you can see the uplink flows between the user equipments and the MEC. And in white, you can see the downlink flows between the MEC and the user equipments. On the left, the remote driving user story, and on the right, the advanced driving user story with the MQTT broker. In advanced driving, we are also showing the cross-border situation with the communication between the MECs. So for the remote driving user story, we have an uplink of the video streaming from the shuttle, and we have a downlink, and we have a communication between the shuttle and the remote control center. The remote control center is sending the control commands to the shuttle, and the shuttle is sending the video streaming and also the confirmation commands to the remote control through the MEC. And for the case of the advanced driving, we have the first in the slide the pedestrian sending the CAN message from the smartphone. We have also the camera sending them messages. We have also the vehicles that are not performing the maneuver sending CAN messages, and we have also the radar sending CPM messages, and the vehicle in blue on the right that is performing the maneuver that receive all the information from the other user equipments, and it's receiving the TEM messages, the CAN messages, and also the CPM messages. Okay, in this slide shows the architecture in extended sensors use case category. In this case, the applications are installed in the ITS center because the latency in this case is not critical, as in the previous cases. Here, the goal is to test the 5G capabilities to send and receive large files. In particular, it is sending the vehicle in white is sending one single file comprising all the sensors information, in red in the slide. And there is other data flow in white from the IT center to the vehicle that collects detected HD maps. In this case, the slide shows the local approach in Spain and also in Portugal. And we have an additional data flow that are the CAN messages sending only for monetization purposes. And this is the third architecture, and is for our vehicle quality of service support user story. In this case, it is also behind the core as the previous one. In this case, with web-based applications. Again, in red, the video streaming from the camera on the bus, and the downlink flow in white from the multimedia service to the bus. Okay, and that was all regarding the plans for the technical evaluation of Spain-Portugal user stories. But in addition, we are dealing with the contribution of the local sites to our cross-border corridor in order to check different designs for the cross-border issues, in particular the ones linked to the telecommunications and application uses. In this slide, you can see the contributions to advanced driving use case category. In the first table, you can see the combined contribution from France and Finland. In this case, They are going to test an onboard unit connected to an intelligent router with dual SIM to check the impact on the roaming and also the continuity of the service. In the second table, the Netherlands use cloud decision, but Spain-Portugal employs in-vehicle decision. So here we will deal with the vehicle-to-make communications and also with the interoperability. Okay, Finland contributes or will contribute with the service discovery. Again, the cross-border issues addressed are the performance continuity, the service life cycle, and the interoperability. And finally, in the second table, Germany is going to deploy its own user story in our corridor, so we expect to get information on the roaming latency, the continuity protocol, vehicle-to-X continuity, interoperability, and on-demand processing. Okay. Well, let's go with the preliminary results in the Spain side and also in the Spain-Portugal border. So in this map shows the cross-border area between Spain, north, and Portugal, south, separated by the Minho River, that is the administrative border. As commented, Telefónica has already deployed 5G nodes in available sites for 4G. You can see these 5G nodes in the slide that are called as Cornetas and also Tuicentro. And the main purpose is to cover the Spanish side of the old bridge and also the new bridge, also in the slide. The configuration used is the 5G non-standalone 3.x in the 3.5 GHz band. Let me remark that the measurements that we are going to show were obtained with a very preliminary version of the radio software. So in next versions, release 5G 19A, throughput behavior is improved, especially in the blue section, and of course, we will continue taking measurements to evaluate the evolution in the performance in the radio part. Okay, this slide shows the line of sight of both antennas, the antennas in the previous slide. The dark areas means that there are not direct line of sight. So it seems the distance to the border, these 1,400 meters, is not as good as desired, is not the optimal one. What does it mean? This means that this long distance could impact on the capacity for downlink transmissions, but it could be even more remarkable in the case of uplink transmissions. In the case of our remote driving user story, it means that sometimes the required minimum bandwidth will not be achievable. The band used is N78, 3.5 GHz, deployed in DDD with 4:1 proportion. So hence, the bandwidth available for uplink is very restrictive. So as lesson learned, it is going to be necessary to consider to use the best possible 5G automotive antenna in order to guarantee the coverage in the positions with more distance to the antenna. Okay, so as commented last February, we performed some tests to obtain the first measurements on the 5G network using instrumental devices, and also with some cameras on a vehicle to test the video streaming for our remote driving user story. In the slide, you can see the two bridges over the Minho River, the new bridge and the old bridge, and the routes performed in the test. In blue, direction Portugal to Spain, and in yellow, Spain to Portugal. And in this slide, we show the results of some of the measurements we performed on the new bridge with two tools, KeySight Memo and also DECRA performance tool. So we have here download throughput, uplink throughput, and also power level. Black color means that there are no throughput at all. Red means low throughput, and yellow and green means high throughput. During the measurements, we reached throughput values close to 150 megabits per second. And we can also say that uplink values are a bit worse than the downlink ones. But let me remark again that these measurements were performed 3 months ago before the fine-tuning of this configuration. In this slide, we have the same results, but for the all bits. As you can see, there are red zones in the middle of the bridge. And again, the uplink is worse than the downlink. And even we observe a loss of 5G coverage in the central north part of the bridge. Okay, in this slide it is compared the throughput values in the previous slide with 2 screenshots of the video for remote driving user story. So the bottom photo was captured in the south part of the bridge and shows a good quality video. But moving to the north, the radio signal decreases, and there are even some cell changes. That means packet loss. And that is why we see the impact on the video frames quality, showing even a blurring of the image that you can see in the slide on the top. Okay. And finally, I'm going to present the Spanish-Portuguese additional method to test the SICAM applications. Okay. This is an optional general strategy to assess the 5G network at the cross-border corridor, performing measurements in radio, MEC, and ITS center. In the slide, you can see that the onboard units and also the rural side units are generating SICAM traffic in order to obtain relevant performance parameters for the different user stories. This means that this enables to assess any user story in any scenario and for the number of times required. Notice that the 5G access network is used to transmit test results in order not to disturb the measurements in the 5G site. Okay, as commented, there is based on a SICAM synthetic traffic. We have also background traffic to stress the network, and this method enables statistical relevance in results. And the measurements on the other side are performed on radio level and also in MEC and ITS center. Okay, this slide shows the hardware and also the main dashboard of this tool. The dashboard is the real-time management of the onboard unit. And the results in the following slides are for the LTE Advanced modem in the onboard unit, but of course, a 5G modem will be installed later. Anyway, both modems exhibit very similar parameters, so we can have an idea of the future results on 5G. Okay, this slide presents an example of several physical parameters. For example, you can see the radio link level, the signal to interference noise ratio, the received signal strength indication, the different antenna configuration, and also transmission power, among others, that have already been measured and can be visualized in the dashboard. All these parameters are geolocated and recorded with the time of measurements, which enables further offline analysis. And in this slide, present an example of how this assessment framework can be used to also analyze application level parameters. So in this case, the MQTT protocol performance, which will be used to transport the multiple CAN and DEM messages in our corridor, is used as an example. The dashboard shows the uplink message latency from the onboard unit to the MQTT broker. And you can see also, for example, the impact of the IT center location on the latency. For comparison purposes, you can see one MQTT located in Lisbon and the other one in London. And this slide presents further parameters related with the MQTT broker, but in this case, when the SICAM messages are delivered to OUs, to onboard units. So you can see the different quality of service of the MQTT from 0, 1, and 2. You can see the run real-time latency that is measured. And also different message size are also addressed in order to understand the impact of the packet size on MQTT message transfer and delivery time and the corresponding latency statistics. And finally, I would like to show you a promotional video of our test last February. In this case, you are seeing the vehicle with our cameras.
Marta, I think we have an issue with the video sometimes with the streaming of it. So probably if we could, I don't know, skip it or.
What you want, please?
Sorry, can you hear me? I think we have a problem streaming with the video,
Okay.
so sometimes it doesn't have the proper flow. If we can skip it, that would be great. So
yeah. That's all for myself. Thank you.
Okay, thank you. Thank you very much, Marta. Now we're going to continue with the next speaker, Mr. Emmanuel Sosa. He's a researcher and project manager at CCG. He's the 5G-MOBIX user acceptance task leader, and he will talk us about user acceptance evaluation. Hello, Emmanuel. Hi, can you hear us? Hi, Emmanuel, can you hear us?
Are you hearing me now?
Yes.
Okay.
Hello.
Hello. Can you see my presentation in presentation mode?
Yes.
Okay.
Yes.
So thank you very much for your presentation. My name is Emmanuel Souza, and I'll be doing a presentation and discussing a bit the user acceptance evaluation that we are planning to conduct on the Spain-Portugal Cross Border Corridor. Okay. I'll start just by referring our objectives. So our goal is to evaluate the acceptability of the several use cases that will be trialed on our corridor, but not just to evaluate the CCAM use cases, but to also try to understand how that service continuity breaks that may result from the border context, from the roaming and handover processes, and from the differences in terms of application level between the networks of the two countries, how that may affect the acceptability of the use cases. And we want to do that with real users, with passengers on the vehicles, with drivers, with the remote drivers in the use cases. And to do so, we are planning to do it through self-assessment. So we ask people to evaluate either quantitatively or qualitatively their experience and their level of acceptability, and also to observation, to actually observe their behavior and how they behave, and to have a secondary metric. Now, this has some challenges. One is that the trials offer kind of little opportunity for the users to interact with the systems. Most of our vehicles will have to be driven by professional drivers. And because it's a lot of use cases involve autonomy, most of the systems are automatic. So the user is not expected to intervene. So it's hard to evaluate the interaction when sometimes there isn't interaction. Also, it can be difficult to separate what is the generic user experience of a CCAM use case from some effect of the technology. And in this case, the effects of the service continuity breaks. Users, they judge what they see and what they experience as a whole. And they pretty much are unaware of individual technology components and how that may affect their overall experience. So our approach is to, well, it's a multi-level approach. Try to have test users taking part on the trials as a passengers of the vehicles. So as observers, not on the driving wheel, because we can't. But also to evaluate the experience of the professional and the remote drivers. They can serve us almost as case studies, although we don't have a lot of sample, but we can have a case study and get their feelings, their impressions and their insights about the experience of driving these vehicles. And we plan to evaluate this in two different contexts. One is when there will be no connectivity breaks in the local trials that were already mentioned. And then a second one with connectivity breaks that is specifically on the border. By comparing these two experiences, we hope to disentangle what is a CCAM user experience from what are the effects of the technology and of the border context. And to do so, we'll be using user inquiring, a quantitative user inquiring to validate the psychometric scales, and also qualitative assessment to open questions in interviews or in focus groups. And through observation of events. For instance, if there occurs some forced takeover from the automated systems, hopefully there will not be, but if they occur, we'll be measuring all that and counting all them, and also analyzing the behavior of the participants. So how often do they glance to the roads, to the other cars, and to other elements. So our psychometric evaluation, we are using a user acceptance model that is based on a very well-known model of technology exceptions developed by Davis, that predicts that the intention to actually use a technology can be explained by the perceived usefulness, so how useful the user perceives the technology and how easy to use this technology is. This is a basic model that has been extended throughout the last years to acknowledge to other factors that may also influence these constructs. So we have, for instance, facilitating conditions like if the user believes that the infrastructure in place is able to deal or to support the technology, if the persons around him, if he believes that the persons around him will expect him to use it, if he feels anxiety about using technology, if he feels effective in using technology, if he enjoys using technology, and how well, in general speaking, in objective terms, the technology performs. And because we are dealing with autonomy use cases, it's also important, we believe it will also be important to evaluate how the users perceive trust in the system and how they perceive the safety of the system. So we'll be assessing all these constructs, all these components of the experience. And to do so, we'll be translating this model in the questionnaire, a psychometric scale, where each of these components or constructs will be evaluated to a set of questions. For instance, for the perceived usefulness, a question can be simply, I will find the autonomous vehicle useful in my driving daily life. And this will be assessed through a Likert scale from 1 to 5. And with that, we can have a quantitative assessment of the acceptability of our test subjects. And to complement this, we have more insights and information. Then we have our open answer questions, which we intend to capture particular perks of the experience and understand what aspects of the interaction may or may not work so well. I will now just describe quite shortly, I'll try the protocols that we are planning that will take place during the trials and in parallel with the technical trials. So for instance, for the interurban coupling scenarios, this refers to the lane merge, to the overtaking, and to the HT maps. We'll have a 3-moment evaluation. So we'll start with a participants pool, half Portuguese, half Spanish. And these participants will take part on a pre-test questionnaire with some focus groups interviews that will take place a few days before the trial. Then they will take part on the local trials that will be either in Portugal or in Spain, where they will have the first contact with the use cases, and they will fill a post-test questionnaire and be subject to a short interview. And then they'll take part on the cross-border trial, where after which they will also fill a second post-test questionnaire and again a short interview. And on this stage, we'll also interview the drivers of the vehicles that will take part on the trials. By comparing these two moments, we expect then to disentangle what is the CCAM experience from what is the effect of the technology and of the border, of the solutions deployed on the border. For the interurban public transport, so the bus, the bus that has been discussed, in this case, it will be a bit simpler protocol. We'll be using the actual passengers of the service, and these passengers will just take part on the trial. They'll just travel on the bus, having the service available to them, and afterwards, they will request them to fill a questionnaire through which we'll be able to evaluate their experience and how the technology affects it. And at last, the shuttle, the remote shuttle, it's pretty similar to the first one. So we have, again, a few days before the trial, a group of participants will have the pre-test questionnaire and the focus groups, then take part on local trials, filling the first questionnaire, and then again on the cross-border trials, filling the second questionnaire. And on this point, we'll also interview the remote drivers and try to understand how their experience is affected also from the local and cross-border context. Additionally, and because we are also evaluating on this use case the point of the VRUs of the pedestrian, with that we'll have the cell phone app that will be connected to the network. We will in parallel also talk with these users and have a second parallel tests with this group of users to evaluate also the experience of the VRUs of the pedestrians. Right now, we are on the process of preparing the survey, so we have an initial set of questions that will be subject to a validation so that you can have a consolidated group of psychometric scales. And we are also preparing interviews and the focus group scripts to prepare everything for the trials. And we are preparing the graphical and the textual descriptions of the use cases that will serve as support material throughout the trials and throughout all the phases of the evaluation. This is one of the short examples that we are preparing for the lane merge, where you can see the vehicles well, trying to enter the lane. And sorry, and that's it. Thank you very much.
Thank you very much, Emmanuel. Of course, if you have any question, please, as I said before, send us through the chat box, and we will try to answer. As you can understand, we have already received too many questions, so I'm afraid that we're not going to answer all today. But of course, we will get back to you via email, and the speakers will answer to you the questions that you have raised. Now, I would like to give the floor to Ms. Daniela Carvalho. She's the head of Unit Transport Economics at TIS. She's responsible for supporting for the supporting team for impact assessment activities, and she will talk us about impact assessment. Hi. Hello, Daniela. Hi.
Hello, Pantelis. Thank you. Good afternoon, all. As mentioned by Pantelis, I will present the impact assessment approach for the cross-border case Portugal-Spain, and I'll focus particularly on the general overview of the approach, then on the economic analysis and the business environment, as I have the big challenge of not taking more than 5 minutes. So just quickly, under impact assessment, we are particularly looking to evaluate the impacts of a seamless service provision across borders seen from the socioeconomic perspective. And it includes 3 main interlinked domains: the quality of life, that is how the system affects society in terms of the mobility, the traffic efficiency, and how this enhances the quality of life; the business environment, that is how the system is enabled by its environmental context and how the system can contribute to the development of new business opportunities; but also the economic analysis comprising the cost-benefit analysis, that is, which are the costs and benefits of the 5G mobility, 5G MOBIX solutions, taking also into account the societal perspective. Just starting by the economic side, we are looking to quantitative and qualitative impacts, mainly measured as savings between a situation with and without the project. But we are framed by specific challenges in implementation. The first one is to adapt a traditional approach for heavy infrastructure investments to less intensive, though still costly measures, and to start from the short-term costs to long-term impact benefits. Then, not all the costs and savings are possible of being monetized. Nevertheless, we expect to come out with traditional indicators for cost-benefit analysis, and this type of analysis established in accordance with European Guide for Cost Benefits. So we'll come out with economic net present value, economic rate of return, economic benefit to cost benefit ratios. Well, we just heard a few minutes ago our project officer referring that it's difficult to see the return of investment from a financial perspective. and this gives us the importance to evaluate that return of investment from the societal side, counting with the socioeconomic benefits. Well, just let me take 1 or 2 minutes to show an innovative solution that is being developed by our partner Siemens, using drones to measure the traffic safety indicators, which results hopefully will feed the economic analysis. They are mainly measuring 3 indicators, so the time to collision, the post-encroachment time, and the time headway. On the business environment, we are particularly looking to understand the context and the ecosystem of the cross-border as an enabler and a facilitator for the large-scale implementation of servicings, considering both the transport but also the communication and 5G sides. Just to highlight 2 or 3 of the several aspects that are good enablers for our long-term objectives. First, we are dealing with a cross-border case that is characterized by a long-time cross-border cooperation with the different European groups of territorial cohesion that are in place, and one of the cases is exactly the Euro region, Galicia, North Portugal. Then this corridor is one of the identified 5G priority corridors in the forthcoming CEF2 regulation. We are dealing with the busiest border between Portugal and Spain, which counts with more than 10,000 daily commuters that every day cross the border to work on the other side. And it's a cluster for business with a good number of structures that are promoting cross-border collaboration. But if on one side this is happening, we are also having on the side of the policy and on the legal and institutional setting, a good case to characterize this border with 5G strategies in place, which are even recognizing already the relevance of this border for the tests and for the potential large-scale deployment. Finally, just a note that up to now, we are mainly working on the preparation of methodologies and the business analysis and preparing all the data sets. And we are hoping that after all this COVID solving, we'll start next year with the tests and we'll start getting some real data to feed the economic and the business and the quality of life impact assessment methodologies. So thank you for your attention. I think I've managed with the 5 minutes. Thank you.
Thank you very much. It was perfect. Now I would like to ask Mr. João Moutinho to continue with the presentation. He is the head of Urban and Mobile Computing Department at CCG. He is the 5G-MOBIX Portuguese coordinator, and he will talk about the conclusions and outcomes from the Spanish-Portuguese Cross Border Corridor. Hi, hello, João. Hi, sorry, we cannot hear you.
Okay. So hi.
Now we can hear you. Hi, hello.
Thank you, Pantelis. Thank you for the nice presentation. Thank you all also for attending this webinar and for the patience of getting this long. I'm here to present mainly the conclusions and the outcomes from the Spanish-Portuguese Cross Border Corridor, and I will try to do it in the quickest way possible so that we can have a few questions still in this webinar. So most of this has already been said, so the idea here is basically to conclude and to provide, let's say, an overview of everything that was presented here today. So I'll start explaining what are the expected outcomes and also to provide an example, which I think is always useful for this type of things, as a potential inside solution adoption that will probably come out of 5G-MOBIX, which is something to expect. And then very briefly, the conclusions. So what are the Spanish-Portuguese unique characteristics that we see? So we have a diversity of scenarios, which is very interesting, which is a highway and a non-highway open borders, which is great for exploring the seamless transition that we have been discussing throughout this webinar. So we have the proximity of 2 nearby cities on each side of the border. I will explain a little more about this later. And we will have 2 different and exclusive MNOs on each side of the border. So very good to explore all the diversity scenarios that we want to take from the ICT 18 call from the European Commission. So partner complementarity, as you've seen, we have very good partners with good complementarity in both countries, even in car manufacturers, MNOs, public administration, and public and research institutions. And we also have a very good thing and a very important thing, which is the involvement of the public road authorities in both countries, either from IMT in the Portuguese side, Infraestruturas Portugal also on the Portuguese side, and DGT on the Spanish side. This is very, very much important if we want to have consequences, if we want really to explore the benefits of having 5G in CCAM. And we also have an open border with a strong relation between the 2 adjacent municipalities, as we have seen by Daniela's presentation. This is a very interesting corridor, either commercially speaking or even by the connection that joins these 2 countries. Well, regarding the area, I won't go into much detail. You have noticed that we're talking about the border with the river in between. So you see here, Tui on the other side and Valencia on this side. So we'll be having these 2 bridges that, as it was already explained, they're very close and they provide a very good benchmark for different scenarios that will be explored. And the expected outcomes will basically be related with the application of 5G connectivity to CCAM V2X use cases. Well, with all the variety of possibilities that will come from this safety and efficiency use cases. Another thing is to qualify and quantify from a business perspective the value of cellular connectivity. Well, we all know that there are several ITS-G5 approaches. So when using cellular connectivity and with 5G, we will have new things to explore, and the idea is to qualify and to quantify those differences so that we can leverage the decision process in future initiatives regarding CCAM, and also to enable a wide range of services that connected vehicles will bring with innovative business models, new things that we have not yet considered and that will appear when 5G connectivity is a reality in countries. And for instance, new mobility scenarios, as we discussed mobility as a service, for instance, new enablers like services inside vehicles will come with 5G connectivity that were not possible, or at least in the same way nowadays. And also to take forward cellular connectivity for vehicles and exploring the true benefits of 5G, things like low latency, reliability, security, location, throughput. Well, most of these things are things that can only be done with the help of 5G technology. And of course, also the very important thing that brings us to Spain in Spanish and Portuguese Cross Border Corridor, which is having a border and all the challenges that come from that were already explained. And again, to determine the specific requirements of 5G technologies, of course, as this will be a very important outcome, as it will define the future path of CCAM, and comparing what would be the evolution from LTE V2X to 5G, and the possible coexistence with other technologies such as ITS-G5, as I previously mentioned. And a very important and a last expected outcome that I would say that it's equally or most important than the others, which is to assess costs, complexity of these deployment options, to know if it will benefit commercially and if it's viable. Because if it's not viable, I'm sure that you're all aware that it will probably not be able to be implemented. So these are the main outcomes. And for that, and to conclude, I would like to present an example of a potential insight solution adoption, which I foresee it for the near future as a possible result from 5G-MOBIX. So this is the Eurocity of Tui Valencia. As Daniel described it, it forms Valencia and Tui, both cities on both sides, they form an Eurocity with a strong connection in between. So cultural, commercial, everything. And we have this touristic hotspot with a low populational density area. So like George, the PO, mentioned at the beginning, we have this low density with this sparse populational area here that typically would not be the first investment in 5G. So the idea here is to bet on this area so that it's a joint effort between the public funding and private funding to get 5G services in this seamless connectivity between countries in a city or in an area that would not be a first priority for MNOs, for instance, or other stakeholders. So municipalities share this commercial bond, and we know that these municipalities, they share the common interests of tourism. And so establishing a viable, useful, and ubiquitous, and also safe transportation link between these two cities would probably be a compelling challenge that can be enabled with 5G-MOBIX. Because as you remember, one of the use cases that we were presenting is a shuttle, right? A shuttle that will cross this bridge. In this case, an automated shuttle that will have several challenges that will be explored in 5G-MOBIX. So as you see, we will have different MNOs, so NOS on the Portuguese side and Telefónica on the Spanish side. We will have technological challenges. As you know, autonomous vehicles are not yet a reality, so they face strong challenges in providing vehicles to do what now people do very naturally. And of course, inter-country regulations and management. We have different countries, different rules. Sure, we drive on the same side of the road in Spain and Portugal, but there are different regulations and also different traffic management centers and ITS centers. So there are a lot of challenges here that need to be really addressed. And of course, safety. As we are talking about the presence of tourism, we will have pedestrians. As Emmanuel explained, the pedestrians are also a very important part of the equation, and they can now be considered in cellular communication, because in ITS G5, it was not that easy or possible to consider pedestrians in the equation. And they are actually acting as vehicles because they have smartphones that can be and they can be compared with OBUs, and they actually move on the same channels that vehicles do. So it's very important to understand the presence of VRUs and to explore them in the context of 5G, and also to access the user acceptance, as it was explained by Emmanuel previously, either from passengers or pedestrians. So, and finally, economical sustainability. So the idea here is to explore all this. That will be actually outputs from 5G-MOBIX and from the user stories that will be explored, and maybe to evaluate, who knows, in the future, if we can have a use case transported to a real-life applications where we have a vehicle crossing the border, users that will have smartphones that will roam between countries with all the technological challenges and the connection challenges of going from a country to the other without service interruption, and also of having non-connected VRUs, people that don't carry a smartphone or don't have any connectivity at all, so that they can be considered, and that at the end of the day, we have a shuttle service between Tui and Valencia operating tourists with a lot of 5G services running inside, like HD movies or something inside of providing extra connectivity and services. So this is a vision, this is an example, so that we can get a real grasp on one of the outputs that may come to real life after 5G-MOBIX, and providing all the outputs that hopefully we want to do so that the European Commission can leverage and support future decisions in CCAM. So the conclusions, and very quickly, so this is a joint effort in preparing the future of 5G in CCAM. We have a very good geographical context for doing it, this cross-border, and in 5G-MOBIX, considering also the Greek-Turkish corridor together and with the other ICT 18 projects, I think we cover a great deal of situations that will really help the project, will help the European Commission in its mission to explore CCAM for the future. And also, the diversity of user stories is also a great thing. Technical evaluation, user acceptance, and impact assessments will, of course, be valuable information. And some of them and some really important developments may really turn into applications in the near future. So I thank you all for the attention, and I'm really sorry I was quite quick, so that we can go for questions. And I thank you for your attention. And again, I'll be pleased to answer any questions you may have via email or even in this webinar. Thank you again.
Thank you, Joao, very much. We have, as before, we have already received many questions, and we have exceeded time. So I think the most fair is to answer you all via email, not just only for 2 questions. We are already, as I said, not far from the agenda. A few questions have been asked. My colleagues have informed me through the chat box. I'm going to share a PDF in the website with the questions and the answers. Now, the whole webinar has been and will be available at the project website, because many questions from the participants. We are going to share with them the presentation that we have made within this webinar, or if watch again this webinar. So in a few days, I think the ERTICO team will upload it at the website. I would like to warmly thank you all for participating in this webinar. I would like the speakers, and of course a warm thank you to ERTICO Academy for hosting this webinar. So I would like to end this one, and again a warm thank you to all of you for your participation. Thank you very much, and have a nice evening.